All right, so this one, of course, this one's a little different. What I notice here, though, is x squared plus 2x minus 8. I'm anticipating that this is going to factor, okay? Let's set that aside, though, and we'll do it, I'll do it below. I guess I'll do it on the side. So let's take that denominator. Let's just see if it can be factored. Oh, why am I factoring? It's because this one is already two binomials right here. I'm anticipating that this is actually going to break up into x plus 4 times x minus 2. Let's find out. All right, so I need two factors of negative 8 that add up to 2. I'm going to choose positive 4 and negative 2. Boom, that works. And what happens? Well, since the leading coefficient is a phantom 1, we have x terms in both binomials. And then we have a positive 4 and a negative 2. Those are the other two terms. And yeah, what happened? We have x plus 4 times x minus 2. That's generally the way this works. I mean, maybe in the future they're not going to match. Right now, since we're just getting used to this, they match, and that's pretty convenient, okay? So rewriting this, all right? So I'm going to take the full thing. I'm going to, again, I'm working downwards here. But now, I'm going to take that, instead of x squared plus 2x minus 8, I'm going to cover that up, and I'm going to replace it with its factored form as x plus 4 times x minus 2, like this, all right? Now, even right here, you could say the negative 10x minus 16. You could probably factor something there. Is it going to do us any good? I don't think it will, but it possibly could, okay? Well, we'll come back to that later. In any case, this denominator has an x plus 4 and an x minus 2. What's missing then, at least from the first fraction there, the x plus 4, it's missing an x minus 2. But again, if I multiply it in the denominator, I got to multiply it in the numerator as well. And yeah, I got the x on the, some people would say the wrong side. It's just a side. It's a different side. But continuing this, okay, now I've got this x minus 2, right? Well, it's missing an x plus 4 in the denominator being multiplied, so I got to multiply this by x plus 4. Yeah, sorry, it's kind of cluttered there, but I got to do it in the numerator as well, okay? So every denominator has an x minus 2 times x plus 4 now. That allows me to rewrite this without any of the denominators. So it's now x minus 2 times the x minus the 6 times the x plus 4. And this would equal negative 10x minus 16.
We don't want to try to break that?
We're not going to break this up because after I get this distributed, I'm expecting an x term that I can combine this with with principles of equality. Same with a constant. I'm expecting a constant that I can combine this with. If I factor stuff out, I'm actually going to have to redistribute it and then do that same thing anyway.
Okay,
So yeah, hopefully that will be a little bit more clear as we move forward here. So let's distribute the x, right? So x times x, that would be x squared. And then x times negative 2 would be negative 2x's. So that's the first distribution. Again, this is negative 6 times x, which would be negative 6x, but also negative 6 times 4, which would be negative 24. And yep, this still equals negative 10x minus 16. Okay, is there any like terms that I can combine? Sure is. I got negative 2x's and negative 6x's, which would be negative 8x's. Okay, so I got x squared still, and then negative 24, and this still equals negative 10x minus 16. Okay, now, when we've seen this before, right, where if we have some kind of trinomial, it's nice if it equals 0 because then we can just factor this out and then figure out what factors would make that equal to 0. So that's what we're going to do, but we're going to force this to equal 0. I'm going to put the 0 on the right. You could, if you wanted to, pull all this stuff over to the right if you wanted to, but I'm going to get rid of that negative 10x minus 16, okay? That's a little better. So with the principle of equality. So get rid of that means I'm going to zero it out. I'm going to do 2 in one step here. So I'm going to take that negative 10x and add 10x. Now, since it's an x term, I'm going to combine it with the other x term on the left. That's the negative 8x's, right? Okay, now negative 8x plus 10x, that's going to end up being a positive 2x. And then the negative 16 also, I'm going to zero that out by adding 16 to both sides. But again, I'm adding the 16 with another like term, a constant, negative 24 there. That's going to end up being negative 8. So this is all going to equal, everything on the right just ends up being a 0. And then my x squared, nothing to combine it with, it just drops. Okay, so we're looking at this. Now I have a trinomial, but I need a little bit more space. X squared. Oh, it is, isn't it? Thank you. Yeah, it's the same. We've already factored it. So let's not do it again. Although you could, you know, if you really enjoy that stuff. So we got the two binomials. This is going to equal 0. And we had it at x plus 4 and also x minus 2. Well, that's nice. We're not there. We're not quite there, right? So that means if I could get x plus 4, if I could just get that to equal 0, that'd be really nice. So if I drop this, if I can make this x equals, then x would equal negative 4. Now that should be one solution. Let's check the other one. So that'd be x minus 2 should be 0. If I could make that 0, then it'd be true. So I'm going to take the negative 2, add it to both sides. That zeroes out. I get now x equals positive 2. Okay, so this should be my two solutions. But here is a problem, okay? In these two solutions of negative 4 and 2, negative 4 is going to make this denominator 0. That's no good. And by no good, that means it's not actually a solution. Okay, we can't have undefined values in our math. But also, some of you notice, well, what if you put 2 in right here? Well, that'd be 2 minus 2 in the denominator. That gives us a denominator that's 0. That can't happen. 2 also cannot be a solution. That tells us then that there are no solutions. Just a DNE situation. Now, what happens, you could say, well, what happens if you replace the x's with negative 4? Well, you're going to get an error in your calculator if you say, well, x is negative 4 here, here, and here, and here, and here, and here. Okay? Well, what happens if you replace x with 2 in the calculator? Put it here, 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 and here. Okay? Doesn't matter. It's still going to say it's an error. The reason why it's an error is, and it may even say on these calculators, I think it says it's a divide by 0 error. It's saying that you have a 0 in your denominator, which cannot happen. These two values then are not part of the domain, which we've done before. Okay? So this one, since both answers that we got, yeah, they're not actually solutions. And again, yeah, we are assuming that I did all the math here correct. It looks good to me, but that should be the solution. Our final answer here is no solutions, does not exist.